is a piecewise function they're wanting us to evaluate. So when we do that, we have to find a certain value. They want here f of -7. So the way this function works is you use the top expression, which is 6x, if your x value is less than or equal to -1. And then you use the lower value, the lower expression, which is x minus 5, if your x is greater than 1. So they're wanting me to plug in an x that's -7. I'm going to use 6x. So 6 times -7 is -42. So my answer 21 would be -42. If I had been plugging in an x value that was bigger than -1, I would have done x minus 5. 22. A rug is to fit in a room so that a border of even width is left on all four sides. If the room is 15 by 21 and the area of the rug is 216 square feet, how wide will the border be? 15 by 21, and we've got this rug inside the room. And this rug has an area of 216. They want to know how wide is this border going to be. Alright, so this width here is going to be x, and this will be x. So the length of the room, instead of it being 21 feet, the length of the rug, is going to be 21 minus 2x. And the width of this room, if I take x off of both sides, where x is the width of the border, this side is going to be 15 minus 2x. This side of the rug is 15 minus 2x. And that will equal the area, which is 216. So now I just have to solve for x. And we'll get two values, but only one will work in the context of this problem, likely. So when you do FOIL, 21 times 15 is 315. 315, then do your outers, that'd be minus 42x, and your inners will be minus 30x, and then plus 4x squared equals 216. So 4x squared minus 72x, let's see, 315 minus 216 is plus 99 is equal to 0. Then you can decide if you want to factor that or if you want to do the quadratic equation. Might be quadratic formula might be faster. So if I did quadratic formula, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Alright, and then what's underneath here, so that's 72 plus or minus the square root of, if I do the part that's underneath, I think I get 3,600. I did a little bit ago. Yep, 3,600 over 8. So that's 72 plus or minus 60 over 8. So if I do 72 plus 60 and then divide that by 8, I get one possibility for x is 16.5. And if I do 72 minus 60, I get 12 divided by 8. I get x as 1.5. So the width of the border can either be 16.5 feet or 1.5 feet. Well, 16.5, while it may solve this quadratic equation, it doesn't make sense in the application, the context of this problem. So the width of this border is going to be 1.5 feet. Alright, problem 23. The vertex of the parabola. The vertex, to find the x-coordinate of the vertex, is -b over 2a. So a is 3, b is -12, and c is 2. So x is equal to -b, so I make it a positive 12, because it was a -12, over 2 times a, 2 times 3, so 12 over 6 is 2. So the x value is going to be 2, so I know this is going to be my answer, because it's the only one with an x value of 2, but let me plug it in to make sure. 3 times 2 squared, that's 4 times 3, that's 12 minus 24 plus 2, which is -10. So my answer is 2, -10. Don't forget, x equals -b over 2a to find the vertex. Another thing you could do is you could graph this on your calculator and find, this will be opening upwards, you could find that minimum point, and that'll be the vertex. Alright, problem 24. I guess this is another one of finding the vertex. So x equals -b over 2a, so that'd be a positive 13 over 2 times 1, which is 13 halves. And so now I'm down to it being a or c. And then I'm just going to plug in 13 halves. for x and see what I get. I'm going to use the calculator here. 13/2 squared. Maybe. Clear. 13/2 squared minus 13 times 13/2 plus 6. And I'm going to get a decimal probably, and so I'm going to hit math, enter, enter, and I get negative 145 fourths. So it'd be negative 145 fourths. The answer will be A, 13/2, negative 145 fourths, just by plugging that 13/2 in. This one also, you can find the minimum point using your calculator. It's just going to give you a decimal, not a fraction answer. We use synthetic division to find the quotient and the remainder. So here's the dividend, here's the divisor. If I'm dividing by x minus 1, I'm going to put a 1 on the outside. It's kind of the 0 of that function. Set it equal to 0, solve. And then over here, I'm going to put the coefficients of each term, making sure that I'm accounting for every single term. Like this one has a fifth, x to the fifth, x to the fourth. It doesn't have an x to the third, so I need to put a 0 in that spot. So 2x to the fifth minus 1x to the fourth, 0x cubed, 3x squared, negative 1x, and 5. Bring down the 2. 1 times 2 is 2, and then you add. 1 times 1 is 1, and then you add. 1 times 1 is 1, and then you add. 3 plus 1 makes 4. 1 times 4 is 4, and then I add, and I get 3. 1 times 3 is 3, and I add, and I get a remainder of 8. So it would be, and now I'm going to start with 1 less power of x, 2x to the fourth, plus 1x cubed, plus 1x squared, plus 4x, plus 3, with a remainder of 8. So my answer is A. Alright, number 26. I'm going to put a negative 1 on the outside. It's going to be 2x cubed, 3x squared, 4x, and minus 10. So this wasn't missing any. So bring down the 2. Negative 1 times 2 is negative 2. Add, you get 1. Negative 1 times 1 is negative 1. Add, you get 3. Negative 1 times 3 is negative 3. Add, you get negative 13. So the remainder is going to be negative 13. So this is going to be my answer right here. That'd be 2x squared plus 1x plus 3 with a remainder of negative 13. Alright, that's 26. 27, find the vertical asymptotes. Okay, the vertical asymptotes of the function. Well, you got to factor the top. Make sure you don't have any factors that are the same. And since it's x squared minus 100, it'd be x plus 10x minus 10. And the bottom's already factored. So the vertical asymptotes, make sure you don't have any common factors. We don't. You set the factors of the bottom to 0. You find the zeros of your denominator. That's how you find the vertical asymptote. So I have a vertical asymptote at x equals 2 and at x equals negative 4. So my answer would be A. In 28, find the horizontal asymptotes. So the horizontal asymptotes, you're going to look for the degree. And when the degree of the numerator is smaller than the degree of the denominator, then y equals 0 is the horizontal asymptote. When they're equal degrees, then you take the coefficients. And these have equal degrees. They're not written the same way. The top's x squared plus 3x plus 2. The bottom, if we wrote it in descending power, it'd actually be negative x squared plus 9 if I wrote it in the same order. So if you'll look, this has a degree of 2 and the denominator has a degree of 2. So the horizontal asymptote is going to be y equals, and then I take the coefficients of these two and divide them. So it's 1 divided by negative 1, so which is y equals negative 1. And that's my horizontal asymptote. Number 29, find the oblique asymptote. To find the oblique asymptote, you do synthetic division. So I'm dividing by x minus 3. I put a 3 on the outside. Then it's 1, 7, negative 6. Bring down the 1. 3 times 1 is 3. Add, you get 10. 3 times 10 is 30. You get 24 for remainder, but the remainder doesn't matter. It's y equals 1x plus 10. That would be the equation of the oblique asymptote. And number 30, find the inverse. I'm gonna save 30, so I'm gonna stop at 29.